Managing attributes with Python's property. With Python's property, you can create managed attributes in your classes. You can use managed attributes, also known as properties, when you need to modify their internal implementation without changing the public API of the class. Providing stable APIs can help you avoid breaking your users' code when they rely on your classes and objects. Properties are arguably the most popular way to create managed attributes quickly and in the purest Pythonic style. In this course, you'll learn how to create managed attributes or properties in your classes, perform lazy attribute evaluation and provide computed attributes, avoid setter and getter methods to make your classes more Pythonic, create read-only, read-write and write-only properties, and create consistent and backward-compatible APIs for your classes. You'll also write a few practical examples that will use property for validating input data, computing attribute values dynamically, logging your code, and more. To get the most out of this course, you should know the basics of object-oriented programming and decorators in Python. So now you know what's going to be covered, let's get started. Managing attributes in your classes. When you define a class in an object-oriented programming language, you'll probably end up with some instance and class attributes. In other words, you'll end up with variables that are accessible through the instance, class, or even both, depending on the language. Attributes represent or hold the internal state of a given object, which you'll often need to access and mutate. Typically, you have at least two ways to manage an attribute. Either you can access and mutate the attribute directly, or you can use methods. Methods are functions attached to a given class. They provide the behaviors and actions that an object can perform with its internal data and attributes. If you expose your attributes to the user, then they become part of the public API of your classes. Your user will access and mutate them directly in their code. The problem comes when you need to change the internal implementation of a given attribute. Let's say you're working on a circle class. The initial implementation has a single attribute called radius. You finish coding the class and make it available to your end users. They start using Circle in their code to create projects and applications. Now suppose that you have an important user that comes to you with a new requirement. They don't want Circle to store the radius any longer. They need a public diameter attribute. At this point, removing radius to start using diameter would break the code of some of your end users. You need to manage this situation in a way other than removing radius. Programming languages such as Java and C++ encourage you to never expose your attributes to avoid this kind of problem. Instead, you should provide getter and setter methods, also known as accessors and mutators respectively. These methods offer a way to change the internal implementation of your attributes without changing your public API. Note that getter and setter methods are often considered an anti-pattern and a signal of poor object-oriented design. The main argument behind this proposition is that these methods break encapsulation. They allow you to access and mutate the components of your objects. In the end, these languages need getter and setter methods because they don't provide a suitable way to change the internal implementation of an attribute if a given requirement changes. Changing the internal implementation would require an API modification, which can break your end user's code. Technically, there's nothing that stops you from using getter and setter methods in Python. On screen, you can see how this approach would look. Here, you create point with two non-public attributes, _x and _y, to hold the Cartesian coordinates of the point at hand. To access and mutate the value of either x or y, you can use the corresponding getter and setter methods. First, you create the get and set methods for x, and then for y. Save this code into point.py and you'll be able to import the class into your interactive shell. Note that Python doesn't have the notion of access modifiers such as private, protected, and public to restrict access to attributes and methods. In Python, the distinction is between public and non-public class members. If you want to signal that a given attribute or method is non-public, then you have to use the well-known Python convention of prefixing the name with an underscore. That's the reason behind the naming of the attributes _x and _y. Note that this is just a convention. It doesn't stop you and other programmers from accessing the attributes using dot notation as seen on screen. However, it is bad practice to violate this convention. On screen, you can see how you can work with the point class in your code. First, you import the point class, and then you create an instance of it with x and y values. With getX and getY, you can access the current values of _x and _y. You can use the setter method to store a new value in the corresponding managed attribute and confirm that it's changed. You can also confirm that Python doesn't restrict access to non-public attributes. Even though the code you've just seen uses the Python coding style, it doesn't look Pythonic. The getter and setter methods don't perform any further processing with _x and _y. You can rewrite point in a more concise and Pythonic way. This code uncovers a fundamental principle. Exposing attributes to the end user is normal and common in Python. You don't need to clutter your classes with getter and setter methods all the time, and that sounds good. It does raise the question though, how can you handle requirement changes that would seem to involve API changes? Unlike Java and C++, Python provides handy tools that allow you to change the underlying implementation of your attributes without changing your public API. The most popular approach is to turn your attributes into properties. Properties represent an intermediate functionality between a plain attribute or field and a method. In other words, they allow you to create methods that behave like attributes. With properties, you can change how you compute the target attribute whenever you need to do so. For example, you can turn both x and y into properties. With this change, you can continue accessing them as attributes. You'll also have an underlying method holding x and y that will allow you to modify their internal implementation and perform actions on them right before your users access and mutate them. Note that properties aren't exclusive to Python. Languages such as JavaScript, C#, Kotlin, and others also provide tools and techniques for creating properties as class members. The main advantage of Python properties is that they allow you to expose your attributes as part of your public API. If you ever need to change the underlying implementation, then you can turn the attribute into a property at any time without much pain. In the next section of the course, you'll start working with properties in Python. Getting started with Python's property. As you've seen, Python's property is the Pythonic way to avoid formal getter and setter methods in your code. This function allows you to turn class attributes into properties or managed attributes. Since property is a built-in function, you can use it without importing anything. Additionally, property was implemented in C to ensure optimal performance. Note that it's common to refer to property as a built-in function. However, property is a class designed to work as a function rather than as a regular class. That's why most Python developers call it a function. That's also the reason why property doesn't follow the Python convention for naming classes. This course follows the common practices of calling property a function rather than a class. With property, you can attach getter and setter methods to a given class attribute. This way, you can handle the internal implementation for that attribute without exposing getter and setter methods in your API. You can also specify a way to handle attribute deletion and provide an appropriate docstring for your properties. On screen, you can see the full signature of property. The first two arguments take function objects that will play the role of getter, fget, and setter, fset methods. Fget is a function that returns the value of the managed attribute. Fset is the function that allows you to set the value of the managed attribute. Fdel is a function to define how the managed attribute handles deletion. And doc is a string representing the property's docstring. The return value of property is the managed attribute itself. If you access the managed attribute, as seen on screen, then Python will automatically call fget. If you assign a new value to the attribute, again as seen on screen, then Python calls fset, using the input value as an argument. Finally, if you delete it as seen on screen, then Python automatically calls fdel. Note that the first three arguments to property take function objects. You can think of a function object as the function name without the calling pair of parentheses. You can use doc to provide an appropriate docstring for your properties. You and your fellow programmers will be able to read that docstring using Python's help. Doc argument is also useful when you're working with code editors and IDEs that support docstring access. You can use property as either a function or a decorator to build your properties. In the next two sections of the course, you'll see how to use both approaches, starting with using property as a function. Creating attributes with property. You can create a property by calling property with an appropriate set of arguments and assigning its return value to a class attribute. All of the arguments to property are optional. However, you typically provide at least a setter function. The example seen on screen shows how to create a circle class with a handy property to manage its radius. First, you create circle. The class initializer takes a radius as an argument and stores it in a non-public attribute called _radius. Then you define three non-public methods. _get radius returns the current value of _radius. _set radius takes value as an argument and assigns it to _radius. And _del radius deletes the instance attribute _radius. Once you have these three methods in place, you create a class attribute called radius to store the property object. To initialize the property, you pass the three methods as arguments to property. You also pass a suitable docstring for the property. In this example, you use keyword arguments to improve the code readability and prevent confusion. That way you know exactly which method goes into which argument. To give circle a try, save the code into circle.py and run the following code in a Python shell. Note that in this course the Bpython shell will be used. It offers several improvements over the standard shell, including color coding and an improved help reader. But note that all of the commands that you see will run in the standard Python shell, which is typically accessed by typing Python at the command line. First, you import the circle class, and then create an instance with a radius of 42. The radius property hides the non-public instance attribute _radius, which is now your managed attribute in this example. You can access and assign radius directly. Internally, Python automatically calls _getRadius and _setRadius when needed. When you execute the next command, Python calls _del radius, which deletes the underlying _radius. Properties are class attributes that manage instance attributes. You can think of a property as a collection of methods bundled together. If you inspect radius carefully, then you can find the raw methods you provided as the fget, fset, and fdel arguments. You can access the getter, setter, and deleter methods in a given property through the corresponding fget, fset, and fdel functions. Properties are also overriding descriptors. If you use dir to check the internal members of a given property, then you'll find _set and _get in the list. These methods provide a default implementation of the descriptor protocol. If you want to better understand the internal implementation of property as a class, then follow the link on screen to read about the pure Python property class described in the documentation. In the next section of the course, you'll see the more popular use of property as a decorator. Using property as a decorator. Decorators are everywhere in Python. They're functions that take another function as an argument and return a new function with added functionality. With a decorator, you can attach pre- and post-processing operations to an existing function. As you can see on screen, the decorator syntax consists of placing the name of the decorator function with a leading @ symbol right before the definition of the function you want to decorate. In this code, decorator can be a function or class intended to decorate the function. The syntax is equivalent to the following now seen on screen. The final line of code reassigns the name func to hold the result of calling decorator with func as an argument. Note that this is the same syntax you used to create a property previously. On screen, you'll see property being used as a decorator to create a circle class with the same functionality as the previous example where you used property as a function. The decorator approach for creating properties requires defining a first method using the public name for the underlying managed attribute, which is radius in this case. This method should implement the getter logic. These lines define the setter method for radius. In this case, the syntax is fairly different. Instead of using @property again, you see @radius.setter. Why do you need to do that? Take another look at the dir output, of which a selected portion is shown on the slide on screen. Besides fget, fset, fdel, and a bunch of other special attributes and methods, property also provides deleter, getter, and setter. These three methods each return a new property. When you decorate the second radius method with @radius.setter, you create a new property and reassign the class level name .radius to hold it. This new property contains the same set of methods of the initial property with the addition of the new setter method. Finally, the decorator syntax reassigns the new property to the radius class level name. The mechanism to define the deleter method is similar. This time, you need to use the @radius.deleter decorator. At the end of the process, you get a full-fledged property with the getter, setter, and deleter methods. One question that may arise is how you provide suitable docstrings for your properties when you use the decorator approach. If you look at circle on screen, you'll note you've already done so by adding a docstring to the getter method. This code looks fairly different from the getter and setter methods approach. Circle now looks more Pythonic and clean. You don't need to use method names such as _getRadius, _setRadius, and _delRadius anymore. Now you can have 3 methods with the same clean and descriptive attribute-like name. This new circle implementation works the same as the example seen previously. You don't need to use a pair of parentheses for calling radius as a method. Instead, you can access radius as you would access a regular attribute, which is the primary use of properties. They allow you to treat methods as attributes, and they take care of calling the underlying set of methods automatically. Here's a recap of some important points to remember when you're creating properties with the decorator approach. The @property decorator must decorate the getter method. The docstring must go in the getter method. The setter and deleter methods must be decorated with the name of the getter method plus .setter and .deleter respectively. If you check your circle implementation so far, then you'll note that their getter and setter methods don't add any real processing on top of your attributes. In general, you should avoid turning attributes that don't require extra processing into properties. Using properties in those situations can make your code unnecessarily verbose, confusing to other developers, and slower than code based on regular attributes. Unless you need something more than bare attribute access, don't write properties. They're a waste of CPU time, and more importantly, they're a waste of your time. Finally, you should avoid writing explicit getter and setter methods and then wrapping them up in a property. Instead, use the @property decorator. That's currently the most Pythonic way to go. In the next section of the course, you'll see how to create properties that are read-only. Providing read-only attributes. Probably the most elementary use case of property is to provide read-only attributes in your classes. Imagine you need an immutable point class that doesn't allow the user to mutate the original value of its coordinates x and y. To achieve this goal, you can create a point class, as seen on screen. Here you store the input arguments in the attributes _x and _y. As you learned earlier, using the leading underscore in names tells other developers that they're non-public attributes and they shouldn't be accessed directly using dot notation. Finally, you define 2 getter methods and decorate them with @property. Now you have 2 read-only properties, x and y, as your coordinates. Here, point.x and point.y are bare-bone examples of read-only properties. Their behavior relies on the underlying descriptor that property provides. As you can see here, the default dunder_set implementation raises an attribute error when you don't define a proper setter method. You can take this implementation of point a little bit further and provide explicit setter methods that raise a custom exception with more elaborate and specific messages. Here, you define a custom exception called writeCoordinateError. This exception allows you to customize the way you implement your immutable point class. Here, the xSetter method raises a custom exception with a more explicit message. The implementation of the ySetter method follows the same pattern, again with a customized message for the y coordinate. Note the difference in behavior when running the same code as seen earlier on in this section. In the next section of the course, you'll see how to extend this concept, creating attributes that have both read and write functionality. Providing read-write attributes. You can also use property to provide manage attributes with read-write capabilities. In practice, you just need to provide the appropriate getter method, read, and setter method, write, to your properties in order to create read-write manage attributes. Let's say you want your circle class to have a diameter attribute. However, taking the radius and the diameter in the class initializer seems unnecessary because you can compute one using the other. Here's a circle that manages radius and diameter as read-write attributes. The setter method converts the input value for the radius and assigns it to the non-public _radius, which is the variable you use to store the final data. The getter method just returns the radius value which has been stored in the non-public _radius. There's a subtle detail to note in this new implementation of circle and its radius attribute. In this case, the class initializer assigns the input value to the radius property directly, instead of storing it in a dedicated non-public attribute such as _radius. This is to ensure that every value provided as radius, including the initialization value, goes through the setter method and gets converted to a floating point number. Here, circle also implements a diameter attribute as a property. The getter method computes the diameter using the radius. The setter method is worth examination. Instead of storing the input diameter value in a dedicated attribute, it calculates the radius and writes the result into radius. Here you can see circle in action. Both radius and diameter work as normal attributes in these examples, providing a clean and Pythonic public API for your circle class. In the next section of the course, you'll see how to provide another combination of functionality, providing write-only attributes.